Write to the primary. Read from the replica. Guarantee consistency. Without synchronous replication. Look at this terminal. Insert into orders on the primary. Capture the LSN. Pass it to the replica connection. Wait for LSN. The command blocks until the replica has replayed that exact WAL position. Then select the row is guaranteed visible. This is new in PostgreSQL 19. And it is just the beginning. Sequences now replicate with logical replication. The 7-year gap from PG 10 to 18 is closed. Replication slots tell you why sync was skipped. And wall_level auto promotes to logical when you create a slot, no restart. This is a replication engineering release. Let me walk you through every change. 7 replication improvements in 14 slides. Wait for LSN. Read your writes consistency on async replicas. Sequence replication, all sequences and refresh sequences. Slot sync observability, slot sync _skip reason, skip _count, last _skip. Dynamic wall_level, effective _wall_level auto promotes. Accept clause for publications. Conflict resolution improvements. And FDW-based subscription connections. Stay to slide 12, I will give you the complete replication health check query for PG19. Wait for LSN is a new utility command that blocks on a standby until a specified WAL position has been replayed. Here is the pattern. Your application writes to the primary and captures the current WAL insert LSN. It passes that LSN to the read replica connection. On the replica, wait for LSN with the target LSN. The command blocks efficiently, using latches, not polling, until PG_last_wall_replay_LSN reaches or passes the target. Then the application runs its select, which is guaranteed to see the write. A critical design decision, this is a utility command, not a function. Why? A function takes a snapshot when called. Holding a snapshot on a standby can prevent WAL replay, creating a deadlock where you are waiting for replay that your own snapshot is blocking. The wait for command avoids snapshots entirely. Timeout is optional. Wait for LSN with a value of 5000 milliseconds. If the LSN is not reached in time, the command returns. You check the return status or use statement_timeout as a fallback. This command only works on standbys. If you try it on a primary, error recovery is not in progress. Let me compare this to the alternatives. Synchronous replication, every write waits for replica confirmation. Higher latency on all writes, even reads that do not need consistency. With wait for, only the specific reads that need consistency pay the cost. Writes are completely unaffected. Async replication gives you throughput. Wait for gives you consistency, but only when you ask for it. The polling loop alternative, before PG19, you would loop on PG_last_wall_replay_LSN with PG_sleep. This wastes CPU, has race conditions between the check and the read, and takes a snapshot on each call. Wait for uses latches, kernel-level efficient waiting with no snapshot. Use cases. CQRS architectures where commands go to the primary and queries go to replicas. Read after write in API endpoints, user creates a resource, the next page load must see it. Event-driven systems where the LSN serves as a change marker for downstream consumers. Load-balanced read replicas with guaranteed consistency for specific critical queries. This is the pattern that MongoDB calls causal consistency with after cluster time. PostgreSQL 19 brings the equivalent with wait for LSN. Sequence replication. I covered this in depth in our dedicated sequences video, so here is the summary. The problem, since PG10, logical replication replicated table data but not sequences. After failover, serial and identity columns started at 1. Every insert hid duplicate key errors. 7 years of this. PG19 adds all sequences to create publication. Refresh sequences syncs values on demand from the subscriber. A new sequence sync background worker handles all sequences in batches, 10,000 sequences in about 770 milliseconds. Key design point: this is snapshot sync, not streaming. Sequences sync at subscription creation, on refresh publication, or when you explicitly call refresh sequences. They do not stream on every next val. By design, streaming every next val would double WAL volume for a counter you do not need until failover. For the full deep dive with hands-on demo, see our video. PostgreSQL 19 just changed logical replication forever. When slot synchronization does not happen, PG18 gave you nothing, sync failed, but no reason why. PostgreSQL 19 adds slot sync _skip _reason in PG _replication _slots, plus slot sync _skip _count and slot sync _last _skip and PG _stat _replication _slots. Skip _reason tells you exactly why sync was skipped, catalog _smin _mismatch, wall behind, or slot not ready. If skip _count keeps rising and last skip is recent, you have an active problem. PG _sync _replication _slots also respects the promotion signal now. It exits promptly during promotion instead of finishing a full sync cycle. Before PG19, enabling logical replication on an existing cluster required changing wall level from replica to logical in PostgreSQL.conf and restarting. Downtime. PG19 adds effective wall level. When wall level is set to replica, PG19 automatically promotes the effective level to logical when you create the first logical replication slot. When all slots are removed, it drops back to replica. This is huge for CDC adoption. Enable Debezium. Create the replication slot. Done. No restart. No downtime. Remove the slot when you are done. No extra WAL overhead. The new read-only GUC effective wall level shows the current actual level. Show effective wall level. One caveat: this only works when wall level is set to replica. If wall level is minimal, auto promotion does not happen. But most production clusters already use replica. Create publication my_pub for all tables except table audit _log, debug _events. Before PG19, you had two choices for publications. All tables, which included everything, including high-volume audit tables and temp staging tables you did not want. Or a list of specific tables, which meant updating the publication every time you added a table. Both were wrong. Accept inverts the logic. Include everything. Exclude the exceptions. New tables are auto-included. Only the explicitly excluded tables are skipped. Alter publication works too. You can modify the exclusion list without recreating the publication. Common exclusions: audit and debug tables with high volume and no need on the replica. Temporary staging tables. Large blob tables. Tables without primary keys, which cannot be logically replicated anyway. Logical replication conflict resolution gets two improvements. Retain _conflict _info is a new subscription setting. When enabled, the subscriber retains information needed for conflict resolution. When an update arrives from the publisher for a row that was already deleted on the subscriber, PG19 can now detect and report this conflict instead of silently failing. This requires retain _dead _tuples to be enabled on the subscriber. PG19 also adds max _retention _duration. When the necessary retention falls below this threshold, retain _dead _tuples is automatically re-enabled. This balances conflict detection with storage usage. Why does this matter? Multi-primary logical replication, whether native PG or products like PG Edge and EDB PGD, requires conflict resolution. These primitives make PostgreSQL a viable foundation for multi-master topologies. 5 more replication improvements. FDW-based subscription connections. Create subscription using a Postgres_FDW foreign server definition. Reuse existing connection parameters instead of duplicating connection strings. Centralizes credential management. Slot sync now exits promptly on promotion and waits until slots are persisted before returning. PSQL commands \drp plus and \drs plus now show comments for publications and subscriptions. And copy to JSON pairs well with logical replication for ETL pipelines. Export change data as JSON natively without custom formatting. Step back. Logical replication in PostgreSQL has evolved over 9 versions. PG 10 to 14, basic table level pub/sub. No sequences. No column filtering. No row filtering. Manual failover. PG 15 to 16, row and column filtering. 2-phase commit. Logical decoding on standbys. Parallel apply. PG 17 to 18, failover slots. Synchronized standby slots. Logical replication from standbys. The infrastructure for high availability. PG 19, wait for LSN. Sequences. Except. Dynamic wall_level. Slots sync observability. Conflict resolution. FDW subscriptions. PG 19 is the tipping point. The gap between physical replication is easier and logical replication is viable for production has closed. Here is the health check query I promised. One query that joins PG_replication_slots with PG_stat_replication_slots and PG_stat_replication. You get slot name, type, active status, sync status, skip reason, lag in bytes, skip count and last skip time, streaming state, send/write/flush/replay LSN, and reply age. Everything. One query. Also check show effective_wall_level to verify dynamic promotion is working. Alert on, slot sync_skip_reason is not null, lag_bytes above your threshold, active is false for slots that should be active. Add this to Graph Ana, Quatch 2, Analyze. 7 improvements. All production critical. Wait for LSN read your writes without sync replication overhead. All sequences 7-year gap closed. Slot sync observability skip reason, count, and time. Dynamic wall_level no restart for logical. Except exclude instead of include. Conflict resolution retain _conflict_info and dead row detection. PG 19 is where logical replication becomes production complete. If this helped you, subscribe for weekly PostgreSQL deep dives. Comment replicate and I will put the health check query and wait for LSN pattern in the pinned comment.